Welcome everyone to part 2 of our lecture series on model deployment as an API. In part 2 we're going to actually create the API script. Before we get started, an important note is that you actually need to install the Flask library. It's technically not part of the environment we provided for you, so you can activate the environment and then run pip install Flask or conda install Flask at your command line, or optionally you can also install through the Anaconda Navigator by searching for the Flask library. Let me show you how you would install Flask with these methods. I'm going to hop over to Anaconda Navigator. Okay, here I am at Anaconda Navigator. Recall that you have your base or root environment, but you also have any environments that you've activated. For example, I have my ML master environment and a bunch of other environments since I work a lot with different environments in Python. It's up to you which environment you want to work in. The libraries we're going to be using are pandas, scikit-learn, and Flask. So whatever environment you're working with, you have to make sure it has all three of those libraries. And if you're using something like a machine learning master environment, such as applications, you can go ahead and click on it. I'm going to not update right now, so no remind me later. Notice I have JupyterLab and Jupyter Notebook here, but the key idea is that we need to install Flask in some environment. So we have our applications, but we're going to come to environments, and then we have the list of environments here. And what we need to realize is we need to get Flask. So you can search for Flask. Eventually you should see a micro framework based on Verkzug and Jinja 2 and Good Intentions. This is the one we want here. It should just be called Flask. I actually already have it installed, but for example, if we went to an environment that did not have it installed, I'm going to go to, for example, let's see, Game Dev, which is another one of my environments. It's loading up right now. No, remind me later. So I'm going to search again for Flask here. Note it is not installed. So how do I actually install this? What we're going to do is go to not installed, and here we can see now Flask is not installed. So this is an easy way to check whether it's installed or not installed, or whether you need to update it, or whether you've selected it, or just to make it easy on you, you could just select all. So we're in a new environment here that does not have Flask. It says all. You simply just check the box, and then if you go all the way down here, it says apply. Go ahead and hit apply, and it's going to install that package for you. And this should be the way you can install Flask through Anaconda Navigator. And it'll say 11 packages will be installed. That's totally okay. Flask has some dependencies that need to be installed along with it. You would just hit apply here, and then you would keep going until it's installed this. This may take some time depending on your internet connection. It first needs to download the packages and then install them onto this environment. And it's going to remind you over and over again. If you want to update, you can just click yes, or I'll say no, remind me later. But now I can confirm that it's installed by checking installed, searching Flask, and seeing that it shows up when I look for installed. Perfect. So I'm going to be using the actual ML master environment. So I'm going to click on this here, and then I'm going to quickly confirm that Flask is installed, and Flask is installed here. Perfect. I'm going to come back home, and in this particular case, you have a bunch of different options, but as we mentioned previously, you want to make sure that we're running this as a .py file. If you're working with a .py file instead of a notebook, I would actually recommend using JupyterLab. So in that case, you could install JupyterLab in case you don't already have it here, instead of working with Jupyter Notebook. JupyterLab looks extremely similar to Jupyter Notebook, but it has a little heavier of a footprint for a lot more features. And one of the features it has is it's much easier to edit .python or .py scripts within JupyterLab. So what I'm going to do is I'm going to also install, and then I'm going to launch JupyterLab instead of Jupyter Notebook. And as you've gone through this course, you may have accidentally clicked JupyterLab a couple times because of its name similarity to Jupyter Notebook, and you probably would have noticed that they look extremely similar. The one main advantage here is when you're working with a .py script, JupyterLab makes it a little easier to work with. In theory, you could also do this in Notebook, but I prefer working with it in JupyterLab. So I'm going to fast forward until this is done installing. Alright, I fast forwarded, this is now done installing, and you should notice that once it's installed, you see a launch button. So it might reorder some things depending on what you had installed before. I'm going to now hit launch on JupyterLab in order to launch JupyterLab. Okay, so this is what JupyterLab looks like when it launches on your computer. Keep in mind you have this little file search tool, which is really nice. You can easily move around your computer. You want to go to wherever you saved the zip file for the Data Science and Machine Learning Masterclass, and if you note here under model deployment, we have that first model persistence notebook, and then we have serving model as an API. And if you were to double click on this, you would notice that we have serving models and API. I mentioned you do need to install Flask here, and we are going to be working with and writing out the code here. But keep in mind, you shouldn't be running this within a Jupyter Notebook because the Jupyter Notebook will interfere with Flask's capabilities sometimes to run an application because they're both competing essentially against the browser. So I don't like to use a Jupyter Notebook when I'm working with Flask, and realistically, when you're doing some sort of API development, you don't do it in a notebook environment. So let's switch to a .py script, which is essentially just a text file. And as I mentioned a couple times already, please feel free to use any environment you prefer. If you like Sublime Text, use Sublime Text. If you like Atom Text Editor or PyCharm for .py scripts, go ahead and use those. All the code works the same in any development environment. So I'm going to exit this right here, and we're going to go ahead and shut down that kernel, make sure it's not interfering. And I can start a new notebook, start a new console, or start a new text file. I'm going to go ahead and open a new text file. And then what I'm going to do here is I'm going to save this as, so I'm going to say file, save text as. And right now it's going to say save file as. It gives you the entire file path here. So model deployment untitled.txt. I'm going to save this as my new API.py. Save it, and when it's a .py file, you should now immediately, if I go ahead and zoom in here a little bit, you should be able to see some Python syntax highlighting. So if you say print hello, and then notice we have a little dot here. If it's not saved, go ahead and do Control S to save it. That little dot goes away. Now it will print hello. So how do we actually then run this? If you are on a Mac OS or Linux-based system, you should be able to click this plus button and easily open up a command line terminal by clicking Other Terminal. However, this doesn't always work for Windows users. So as an alternative for Windows users, you can come back to Anaconda Navigator and simply install cmd.executable prompt. So if you click install here, what this is going to allow you to do is have a command line tool, which essentially allows you to run Python files at your command line, which if you've ever run a .py file at a command line, you know what that's like. And what's really nice about this is it's going to automatically take into account the applications and the libraries you installed on your environment here. So we'll say no running later, and let's go ahead and launch cmd.executable prompt and launch it, and you'll notice that it's essentially going to have a command line launched for you with your environment activated. So you simply need to cd or change directory to wherever you happen to have that file located on your computer. So my file is located under cd Purion Data Courses, and I call this file Machine Learning Masterclass. And then under there, we can say cd, and I believe the number is, let's see, 24, model deployment. And now, under model deployment, if you're on Windows, you can hit dir. If you're on macOS or Linux, it's ls for listing everything. But here we can say dir, and we should see the my new API file show up. So with our environment activated, and with my new API.py file showing up, I simply need to come here and type Python space, and then the name of the file, my new API.py. Hit enter, and we should see hello, which is what we asked it to print. Okay, perfect. Looks like everything's working, and we're able to run this now. So let's come back to the Jupyter Lab. So we're going to come back to Jupyter Lab here. We have our command line ready to go, and it's time to start programming. All right, so what I'm going to do here is just collapse this folder to give ourselves a little more room here, and let's create our API. First things first, we've got to import a couple of things. From Flask, lowercase f, I'm going to import Flask, uppercase F, request, and JSONify. And all this code is available to you in the API.py file within the notes provided for the course. Then we have from joblib in order to load up our saved model, and then import pandas as PD. So there's a couple things we have to do here. First, we need to create the Flask application. Then I need to connect a post routing call or API routing call. So a post API call to some sort of predict function. And then at the end of the script, what I need to do is load my model And technically I could also do this from the predict function, but it kind of makes more sense to do it right when the model starts or right when the script runs. So I need to load my model and set up the column names. Essentially just load everything of joblib. So we'll also load column names that we saved earlier. So this will be loading all the pickle files. Okay, so we're going to first create our Flask app. That's actually super easy. It's one line of code. Simply say app is equal to uppercase Flask and then underscore underscore name underscore underscore. Note that it's 2 underscores here. Super common beginner mistake to accidentally just put 1 underscore. Okay, so we want to connect this API call to some sort of predict function. The way this works within Python and Flask is you create a function. I'm going to call it predict colon, and then eventually we're going to return something, which is we're going to return the prediction. And in order to connect it to a post API call, we use a decorator. We say @app, which is the app we created up here. Go ahead and route to /predict. So what this actually does, this first parameter into app.route, is it just tells it, hey, if you're on HTTP some local host, and then this is probably going to run in a particular port. You can actually set the port whatever you want. I believe the default port is port 5000. Then you're going to say /predict. This you can think of as the URL that we're going to be running locally, where we're actually going to connect to the hypertext protocol here. Okay, so predict is essentially going to define what this last slash should be. In theory, you can call it whatever you want. Let's match it up with predict here. And then we have to say the methods it's going to accept. So we say methods, and then in a list, pass in a string POST, which is going to be the post method, all caps here. We're essentially saying that we're expecting that if you go to predict, then you should be able to post some information as an API call. So what actually happens when you call something and post it to predict? Well, in theory, it should be accepting JSON. So the things we need to do here is to get the JSON request, which is going to be the JSON formatted feature data. Then I need to convert that JSON into a pandas data frame, so to pandas df. And then what I also need to do is make sure this matches up with column names. So I'm also going to put in parentheses here column names, so set that up. Then I need to predict and return the prediction as JSON. So get JSON request. This is actually super easy. It's within the request capabilities of Flask, so that's why we import a request here. We simply say feature data is equal to request.json. So what's going to happen is when we're using the API, we send a request object. That request object is going to have some JSON in it. We're sending it to predict and we're posting it there, which means it's going to get passed into this function automatically. So you pass in the request, it automatically grabs JSON, and now you have your feature data. Problem is, this feature data is still JSON, which essentially looks like a Python dictionary. So to convert JSON to pandas, we simply say df is equal to pd data frame, and then pass in that feature data. And then what we need to do is make sure the column names match up. So I can say df is equal to df reindex with the columns equal to the call names. Now right now, call names is not defined. We're going to define it when we actually load our model up here when we first start running the script. So we'll talk about this later on. Once we have this data frame ready to go, we are going to pass it into our model. So we're going to say prediction is equal to, and I'm going to return a list form here. I'm going to say list model.predict df. And again, we don't have model defined. That's going to be defined down here later on. Once we have this prediction, we need to return it as JSON. That's easy to do with this JSONify function call. So we're going to say return JSONify, and then as a dictionary here, I say prediction string prediction. And this will allow us to return JSON from a post request to predict. So what's going to happen is the API is going to post something to this hypertext link, essentially, and then you're going to pass in JSON. We're going to grab the feature data from that JSON, convert it to a pandas data frame, grab the prediction, and then return the actual JSON from there. Okay, so what's still missing? Recall, column names has not been defined, nor has model been defined. I could technically define it up here in the predict, but it usually makes more sense to just load that up when you're running this .py script. So we're going to say if underscore underscore name underscore underscore, again, keep in mind this is 2 underscores, is equals to, and then as a string underscore underscore main underscore underscore, this is, then we're going to say colon. This is essentially a block of code that's going to run when you're running this .py file. We're going to load the model and the feature columns. So I'm going to say my model is equal to joblib.load, and recall we saved it as finalmodel.pkl. You may need to pass in the full file path if it's in a different folder. And then we're going to say call names is equal to joblib.load, and then we're going to say column names here. So we're going to say column underscore names. This is also a pickle file. And then after that, start running your app. We're going to say app run. And I encourage you, when it's not in production, to say debug is equal to true. That way, in case we accidentally make a typo here, it's much easier to debug because it gives you a stack trace. Make sure you save, Control S, and let's quickly review what's going to happen. So if I call Python my new API, what's going to happen is I'm going to run these imports, create the application, and then I'm going to load up my model, set up my column names, run this application. With this application running, it's ready for any post request or method call, which is we're going to do with an API to predict, and then we're going to say predict, and we're ready to receive the JSON request, convert it to pandas, get the prediction, and return it as JSON. Coming up in the next lecture, we're actually going to test out this API with the Postman application. I'll see you there.